All right, now that we can perform a linear regression, let's talk about measuring the performance of our linear regression. Now let's simplify things and get rid of all the data points and just use one. If we take the distance from our mean to our data point and we square it and then add them all up with the other errors, we get the sum of squares total. Right? That is the error in relation to our mean. And again, this gives us a general sense for how much error is kind of naturally in the data set. Now, if we take the distance from our model to our data points and square them and add them all up, that's going to give us what we call the sum of square error. It's the error in our model. So how much error our model experienced. Of course, we could just use this as a metric, even divide it by n to get the mean squared error of our model. And this, the lower it is, the more accurate we can sort of say that our model is, since there's less error. However, often in statistics, we use a different value. It's a comparison of our sum of squared error to our sum of squared total. So we take these two values and plug them into this equation, or this formula. R squared is equal to 1 minus the sum of squares error divided by the sum of squares total. Now you can think of 1 as representing that all of the error has been explained. So all the error in our data has been explained by our model. Now, of course, this is generally not the case because models aren't perfect. So we subtract the portion of the error that was left over. Right? The sum of squares error is the amount of error that was in our model, and sum of squares total, again, is the error in relation to the mean, or the sort of inherent error in our data. So we see what portion of that was still left unexplained by our model. And by doing 1 subtract that, we get the error that our model sort of explained away. The portion of the error that our model was able to account for. So for instance, if r squared was, let's say, 0.8, it would mean that 80% of the error was sort of accounted for by our model.